So the size of the array, I would say that this is an array of size 5. But in C++, the size is actually the number of elements times the data width. So a double is 8 bytes wide, so 5 times 8 would be 40. We can prove that. I'm not sure how much longer I'm going to be able to lecture, guys. Let's make an array of doubles. Double DA for double array equals 1, 4, 5.5, I'm just making up numbers. 8, 10, whatever, right? Close curly brace, semicolon. Let's print out the size of the array.
I think you have to initialize how many.
No, you don't. If you leave that out, and yes, you can, but if you leave it out, it counts how many, and it fills it in for you when it compiles.
What about that last time?
Last time we allocated it, and we weren't giving it any data, so we did put a number there. Like this. We still didn't put anything here, but we could have. We could have put nums underscore size there. And that'd be a perfectly valid thing to do. So the last time, last Thursday, I remember what you mean, we were creating a variable that held the size, like const space int space da underscore size equals 1, 2, 3, 4, 5. That's great. And then if you want to, you can do that. But you don't have to. The advantage of doing it this way is that when you use for loops and stuff like that, you have to have a size to know when to stop. But this language, unlike Python and Java, does not give you a function or a method which tells you the length of the array. So you always need some way of figuring it out. And there's two ways. One is to declare a constant like that. Since I'm declaring it here, I should just remove that 5 and fill it in with da underscore size. That would be more correct. da underscore size. Alrighty, let's find out how many bytes that thing takes up. Int bytes equals size of parentheses da in parentheses semicolon. And let's write it out. Cout less than da size is end quote less than bytes less than quote space bytes period \n end quote semicolon. And so it's 5 elements long, and each double is 8. So it should be 5 times 8. It should say that it's 40 bytes long. All right, I have an error. Surprise, surprise. Cout undeclared identifier. Well, that's something I added earlier. And y'all guys who are just watching the video don't even have this code because I forgot to start the lecture. But, all right, so fine. # include iostream in quote # using namespace std. All right, I shouldn't have added that inline method. All right, okay, so the DA size is 40 bytes. True enough. So how do we get the length of the array? The length of the array is the size of the array divided by the size of each individual element. Go away. All right, so for example, what is the size of an element? Int size underscore element equals size of, now what is the data type? What is the array's data type? It is an array of what? Strings, floats, ints, what is it? Did I hear it? Did somebody? Yep, it's doubles, right? It is an array of doubles. So the size of each element equals size of double. The length of the array, int dA underscore length, equals the size of the array, size of dA, in parentheses, divided by size of, parentheses, double. Like that. We could print these things out, just for funsies. Cout less than, element size is, space end quote, less than, size underscore element, less than, quote, space, bytes, period, backslash end, and quote, semicolon. And then lastly, cout less than, quote, length of array is, in quote, or in space, space, end quote, less than, size of, parentheses, dA, in parentheses, divided by size of, parentheses, double, in parentheses, less than ENDL. Now, was it slightly silly to do it this way? Because didn't we already calculate that and store that in a variable? What's the name of the variable that I had stored this calculation in already?
DA length.
Yeah, I could have just put DA length there, right? All right, so the size of the array is 40 bytes. Each element is 8 bytes, and so the length of the array is 5. There's 5 elements in it. We really don't need that hello message anymore, do we? Yeah, we're going to nuke that. All right, there we go. So let's print out the memory address of every element in the array, and let's print out the value of every element in the array. Normally, you just want the value. So let's do that first. For parentheses, int I equals 0, semicolon. I is less than size of underscore DA end. Now see, I'm doing all this business when we've already got several ways of figuring it out, right? I could just use DA size because I have that up here. So why not? DA underscore size, semicolon, I plus plus, cout less than, quote, element space end quote, less than I, less than, quote, equals, end quote, less than, DA subscript I, in subscript, less than ENDL. So it's going to print out elements 0, 1, 2, 3, and 4, which are equal to 1, 4, 5, 5, 8, 10, respectively. And there we go. Element 0 is a 1, element 1 is a 4, element 2 is a 5, 5, and so on. All right. But what if we're curious about what memory addresses these things are stored at? How about this? A pointer to an int, p1, is equal to ampersand, the address of DA subscript 0 in subscript semicolon. And apparently didn't like that. I wonder why.
Gee, I wonder why.
A value of type double star cannot be used to initialize an entity of type int star. Okay, sure. My mistake. Double space star space p1 equals ampersand. So the ampersand means address of. And I want to do the same thing for P2, P3, P4, and P5. So I'm just going to copy that line and paste it 4 more times. Two, 3, 4, 5. 0 or 1, 2, 3, and 4. And then I can print those guys out. Then I better pause and make sure everybody's got the typing going on. Cout less than P1 less than NDL. And I'm going to copy and paste that to make it print out P2, P3, P4, and P5. And so we see each element is at this memory address. Now this is in hexadecimal. We could change them to be in integers if we wanted to by doing int parentheses like that, in parentheses, and putting that in front of each one of them. And so here are the memory addresses, right? And each double is 8 long. So 0, 0, 0, 8, 16, 24, 32. That's the memory where these elements, these values, 1, 4, 5, 5, 8, and 10 are stored. So what if you wanted to change one of those values? What if I wanted to change the first element of the DA array to 7,777. I would type DA asterisk, and what is the first element? What's the subscript? Our subscripts always start with, you can get a real strong hint by this little block here. 0. Yep. So DA subscript 0 equals 7777, right? And DA subscript 1 plus plus. DA subscript 2 equals DA subscript 0 times DA subscript 1, whatever, right? So anywhere that a double would work, an array element of the same type would work. Since it's an array of doubles, they can be used interchangeably. Double D equals DA subscript 3 plus DA subscript 4, right? So you could just do any kind of math operation or assignments or whatever that you could do if it was just a double, right? You could always do plus plus on a double. You could always multiply 2 doubles together. You can always add 2 doubles together. You can always assign a double. Instead, we're just using array elements. So why do you care? Because an array can hold a large amount of data. It can hold a sequence of values, like your MP3 player, your music application. You know, you have 10,000 songs on your Android or your iPhone, and all that data has to be stored in a list so that it can be displayed on the screen as you scroll up and down. That's probably not actually stored in an array. It's probably stored in a more dynamic structure. What do I mean by dynamic? I made this array 5 elements long. If I want it to be 6 elements long, if I wanted to tack on a 6th number down here, maybe the 6th number is the sum of all these 5 numbers, too bad. There's no way to append to it. Unlike Python, where you can just call .add or .append, I forget which one it is, and you can put another number on the list. Doesn't work that way in C++ or Java. Once you declare your array, it's a fixed length.
Can you go down?
Yeah, sure. Yep, that's it. So let's add a comment. Arrays are fixed length. Once declared, the array cannot grow or shrink. You can't delete elements from it, and you can't append elements to it. If you actually need that to happen, you need another data structure. And the book talks about something called vectors. Vectors are a way of making an array that can grow and shrink. If it needs to be, quote, dynamic, end quote, so it can grow or shrink, as required, you would use another data type like a vector, which this chapter also talks about.